So in this video, I'll be going through the concept of conditional probability, which includes this formula, and independence. So this formula, you can read it as the probability of A occurring given that B prime is occurring. So how you think of it is like when B prime occurs, what is the probability that A will also occur? So the formula of this can be written as such. So you always remember that the one behind is the one below. Okay. So for now, I'll just use this formula first. You can go and better understand this concept on your own. I'll just use the formula in order to answer the question. So you see, I'm trying to find this, and this is common here. So in order to find the probability of A intersecting B prime, I would use the probability of A given that B prime has occurred times the probability of B prime. So the question has given that this is 2/3, and the probability of B prime can be given by 1 minus 2 over 5, since this is the probability of B. So if I were to draw a Venn diagram, the probability of B would be this part, and this is 2/5. And so the part that is outside of B would be 1 minus 2/5, because this whole box is actually represented by 1. So the answer would be 2/5. So now let's tackle part 2, where we are to find the probability of A, which is represented by this area in the Venn diagram. So we are given by the question that this part is 2/5. This part is 2/5, and then this intersecting part is 1/10, since the probability of A intersect B is 1/10. So in order to find the probability of A, we are to find this whole part, right? And how do we find this area? This red area. Do you realize that this area is called the probability of A intersecting B prime? So in order to find this out, I would suggest you draw this first in order to visualize it. So let's draw this together. So B prime would be the area that's outside B. So anything outside B. And A would be A here. So you see the part where both are overlapping would be this, the blue section. So this is how you know that this is equivalent to this. So in order to find the probability of A, we need to have this plus the part where they are intersecting, which is also A intersect B. So this is quite a standard formula that you can use anywhere, but I don't suggest that you memorize this because it is quite useless if you just memorize it. So I suggest that you draw everything out in Venn diagrams so that you can visualize what's going on first. So let's do this. 2/5 plus 1/10 equal half. Okay, let's go through part 3, which involves the concept of independence. So what independence means is that the occurrence of event A does not affect the occurrence of event B, and vice versa. So let's say there are two students in two different classes who are not friends and who do not know each other. So there's Sally in class A and Andy in class B. So Sally's attendance is independent of that of Andy. So let's say on a particular date, the absence of Sally, the probability that Sally misses school is independent of the probability that Andy misses school. Since they do not know each other, they are in different classes, they are likely to not be in cahoots with each other, and so these events occurring are independent. So to prove the independence of events A and B, we can show the following. The probability of A occurring given that B occurs is equal to the probability of A occurring. The probability of B occurring given that A occurs is equal to the probability of B occurring, and the probability of A intersect B is equals to the probability of A times the probability of B. So if A and B are independent events, A and B prime, A prime and B prime, and A prime and B are also independent, which can be proven. So they are asking us to state whether A and B are independent. So in order to prove independence, we have these three sets of options that we can choose from. So let's see. We are given this as 110, and then we have found this in part 2, and we are given this in the question as 2/5. So let's see, okay? Let's see whether or not A and B are independent. So in order to test, let's use number 3. Let's see whether this is true. So this is equal to 110, right? And then this we found just now as half, and this is 2/5. So this times this is not equal to this. So we can say that they are not equal, and since they are not equal, A and B are not independent events because of this. And also, if you actually want to prove this, you can do it with the help of this formula. So let's show it. So the first formula, right, is something like this. So we want to prove rule 3, right? And then you see this is known as this. So this is equal to, since this is P.